Okay? Now, 17 is a head gaming problem here, and it's going to require a little bit of knowledge of either how tangents work, I believe it's tangents, yeah, tangents work, or how your calculator can show you how tangents work. And I think it's probably easier to do the graphing part of this. So the f of x here is equal to tangent of 2x. Now, I want to show you what the graph of the tangent of x looks like. This freak show right here, I have two graphs going on here. I have the tangent of x in black and the tangent, or cotangent of x in green. And they are reciprocals of each other. Okay, but you'll notice that there is a distinct pattern between the intervals of tangent, and it's about pi. Okay, so since the period of the tangent of x, and if you graph on your calculator y equals tangent of x, you'll notice that the period is pi. It goes from negative pi over 2 to positive pi over 2, and then it starts all over. The next, all the way up to pi over 2, 3 pi over 2, and then 5 pi over 2, and on and on and on. So it's a periodic thing like that. If you type in 2x, and I caution you that sometimes it's easier to understand if you do them separately and then look at them together, which your calculator will allow you to do. If you put this on your calculator and you take a look to see what tangent of x looks like, and you see, focus particularly on the dots on the x-axis and see how far apart they are, just in terms of the dots, not even in terms of what the pi or pi over 2 means. Now, the default mode for your Zoom 7, which is the trigonometric default mode, is pi over 2. Okay, so you can look at that and see how the curves oscillate, shall we? Not really oscillate, but repeat every pi over 2, or every pi, or how many parts there are. I think it's pi for the tangent of x. So, but then type that in y2 equals that, and then, but don't graph y1, which is equal to tangent of x. So you put your cursor over the equal sign that has the block on it, hit enter, and the cursor sign will go away for the y1, and make sure it's on for the y2. Do the same thing. If it's not on, if there's no block on it, then go down and get the cursor on it and hit enter, and then hit right arrow to make sure it's on. And then hit graph, the same graph, and again, when you do this using Zoom 7, or which is a Z trigonometric standard, take a look at that. Now, if you don't see the difference, if you're looking at the dots, you don't see the difference, then you probably should turn on both of them at the same time and watch how that goes. And I think you'll see a shift and a squeezing. And it turns out that you have a pattern where this right here tells you you're going to have twice as many waves in the same period. In other words, this is saying for every pi, you should get 2 of these curves. Okay? So, and also if you take a look, because of that it's scrunched in half the space of the usual tangent of x, instead of starting at, say, pi over 2, it's now going to start at pi over 4. So, there's a number of ways you can represent this. So we got these asymptotes all over the place, okay? So if you look at it from the positive aspect for this, then I would say that you probably want to say that this is going to be pi over 4, x equals 5 pi over 4, x equals 9 pi over 4, and so on. And then if you go to the negative side, you're going to say that x is equal to negative 3 pi over 4, because it's pi away from that. And then x is going to equal to negative 7 pi over 4, because it's shifting by pi units over each time for the switch. So this is probably what you're going to, and then you say on and on and on like that, because every time you're adding 4 pi to the top to get a pi shift. You can represent this algebraically, which is fine. There is a way of doing that, where you just say pi times n over 4, where n is an integer. And integer means positive 1, negative 1. And that, if you use that, that doesn't really work for the negative value, so it might be best if you put it another way. So you manipulate your values around. So you'd say x equals pi over 4 plus a shift, and this is the way that I would do it, a shift of n times pi, where n is an integer. And that takes care of that issue about the positive and negative. So you could represent it that way, or you could just simply give examples of both the positive and negative side and put and so on there. So the calculation for that is not as easy as the others, but the graphing will help you. And there are going to be times when graphing is a lot easier than the actual mathematical manipulation. So you need to be aware of the things that you can do with your calculator for graphing, because it will make life a whole lot easier for you. Okay, so let's do some of the others here. Number 19, we have capital T sub t is equal to 4 over t squared. Well, that's pretty obvious. So t is going to be equal to 0, will be your vertical asymptote. T sub t would be your y. Little t would be your x. 21 is pretty simple too. We do that real quick over here. We have x, function of x is equal to x over x squared plus x minus 2. And then this is factorable to x plus 2, x minus 1. Nothing can cancel up here. That means x equals negative 2 and x equals positive 1 as your vertical asymptotes, and on and on and on like that. So there's a lot of factoring that's going to be involved in this. So your practice problems I would like for you to do on page 88, problems 10 through 26, even number problems. Okay?